So let's talk about this problem. So the question is that we have the question here. The first, it's actually have like two related question actually. The first one is more like the simplified version of the question. Is like two distinct character, right? So here you want to let's understand the question. Okay, so you want to find the longest substring. Longest substring means it's continuous. Okay, continuous T that contain at most two distinct character. At most two distinct character. Okay, so here ECE have two distinct character E and C, right? You cannot have a better one actually here, right? Where B and A they are distinct, but you only have a length of 2, right? You can have EB here. EB only 2, right? So ECE is the longest, okay? So if you look at the K, right? K here it uses 2, but you can this can be generalized, right? It can have more than 2, right? The K can be like 5, 6, 7, right? So how should we do this, right? So so if you look at our collab editor here, the code, right? I have a solution here on line 178. I'm not going to talk about it because this is not very general to the K. It's only applied for the two distinct character, right? It basically uses three index pointer, I and J and K. So it basically uses 3 pointer to mark the continuous field, like a distinct field. So it works, but it's not very generic, right? So I'm gonna skip here, okay? So this is a solution, okay? So the second one is very generic. Second solution on line 202. This one is very generic, okay? So what's the solution here? So because we're talking about the continuous, right? Continuous. So if we are talking about the continuous, it suggests sliding window, right? So if we maintain a sliding window with the left pointer and the right pointer, and the key is we maintain a map. The map is saving the statistics in the sliding window. If we have the key is the character and the integer is count, right? What can we do here? So let's look at this, right? Let's say this is our sliding window. So this is the index. Let's say we already reached the left is pointing to index 3, and the right is pointing to index 12, right? Here. So we basically the map. How the map looks like. The A have 5 count, right? 1, 2, 3, 4, 5, right? It has 5 count, right? The B has 2 count. 1 and 2, right? The C has 2 count, 1 and 2, right? D has 1 count, right? So this is how the map looks like. So let's look at the code here. So let's look at the collab editor. So here I mentioned this is using count on line 234, but this one is assuming it's 256 ASCII character, right? It's not very generic actually. Right, it's not very generic, right? If you can have like Chinese character and other stuff, it won't work, right? Actually, when the interviewer is asking the candidate to test it, right? What's the test case? The interviewer would like to ask test cases, right? One thing is can be like ASCII, right? Let's say I 189, right? So actually, when the candidates talk about like a Chinese character and like Italian character, the interviewer laughed, was very happy. Why? Anyone guess? Any guess here? Anyone guess it? Why? Why the candidate actually say, okay, maybe this can be like a Chinese character you want test. That's one test case, right? Why does the interviewer laugh? Because it happens that the interviewer is on the internationalization team. He's working in this zone, so he's very happy about it. The interviewer happened to be working on the I-18N, internationalization, okay, multi-language, okay. So that's very a coincidence. It's actually a very good thing actually. So what else can you think about? What else can you think about? What test case can you think about? Empty string, right? Empty string, right? Like a k is too big, right? K is bigger than the length, right? Like a k equals 0, like k equals 0 or k bigger than s dot length, right? Those, right? What else? What else? What else test case? K negative, right? K is negative, right? What else? What else? What else test case? So you need to think about test case, okay? The string. What can we do with the string? The string can be, so it depends on the encoding, right? We already talked about the I18N, right? Encoding. Okay, some students raised. Infinite. What is infinite? What is infinite? The K or the S? Okay, yeah, S is infinite. You mean the stream in, right? Okay, I got you. So that's the follow-up. Okay, the input, it's not infinite, right? Everything is finite, right? You cannot have infinite. It means it's very long. Okay, not infinite. Yeah, it can be another test case. That's actually the follow-up, actually, right? S can be very big, right? So let's look at first. Let's not talk about that for now. Let's first. Yeah, it can be happen, right? Yeah, I think it's a good one. S has character less than K. So that's good. Yeah, that's a good test case. Yeah. Okay, that's a good point. Okay, let's continue. So I'm gonna use the map here because map is all more generic. 253. Okay, map is more generic here. Usually, I suggest you if you prepare your solution, better have a map, right? Because if you go to the phone interview, if you want to copy over your code, right? If we are using the array solution here on line 236, if the interviewer says, okay, we have to go with the map, then you have to spend time to modify it, right? It might not be easy, right? Because here you see the code is quite different here. If you do a comparison, the code can be quite different. Okay, the map and the array can be quite different. The array I think is easier. The map is I think more difficult. So let's look at it here. Line 257, okay? Line 257. So we have 2 pointer as the slide window, right? What else do we need? We want the total. Total is the total number of distinct character in the window, okay? The result is what we want to return, right? The length, right? So basically here, the result we do right minus left plus 1, okay, here, right? And the count is basically every time we try to do, it's just a local variable actually here. Okay, also the char C here, okay? So the right is doing a linear scan towards the right, okay? So that's a sliding window, okay? So on line 258, we get the character C. And we did the count here, right? We did the count plus 1 here, right? So when we put the C here, we do, if it's equal 1 means what? When it's equal 1, it basically jump from 0 to 1, right? So that means we got a new distinct character, right? When it become 1. If it become 2 or 3 or 5, we don't care, right? Because it's already it's just duplicated the character, right? So when 0 become 1, that's what we care, right? We need to increase total, right? Increment total. So when total is bigger than K, that means what? We have extra character, right? We need to we need to decrement the total, right? So we have to do this while loop until we get rid of this this character, right? So we basically need to move the left up, increment the left, right? You get a C, right? And then you have to decrement it, right? Decrement the count, and you need to update the map, right? So until the count becomes 0, right? If we have a character that the count is reduced, subtract from 1 to 0, we here basically when count here from 1 to 0, then we have we remove 1 distinct character, right? That's the condition, right? So once we remove it, we have a total. So that means what? That means the total now is equal to k, right? So our sliding window is back to balance, right? So we need to maintain the balance of the sliding window, right? We need to maintain here inside we have k distinct character, right? Okay. So let's go back. So here basically this is the code, right? So until we remove auto. So during this we want to check the result to be the max, right? So okay, now I'm gonna talk about the follow-up. Before that, let's look at the runtime and the space. Okay. So here we are using extra space. Okay, space. So the extra space is what? The count, the map, right? So how big can it be? So if you are talking about the worst case, right? Worst case, let's say the k. Worst case, just give the interviewer example, okay? Sometimes it's good to give an example, okay? K equal 2, and S is what? Well, so you only have one, since basically student number 27 said, right? S has character less than K. So what's the space gonna take, right? Actually here, the space is also, okay, maybe that's not a good example. Let's say the K is like 10, right? But we have like A, B, C, D, E, F, G, H, right? So it can be as big as, if the K is like bigger than N, right? Let's say tell the interviewer N, always tell the interviewer what N means, right? N is the length of S, right? So actually the space could be ON, right? Right, or OK, right? Right, that's the worst case. What's the runtime? The runtime is still, so we have the right pointer moving, right? So look at the slide, right? So here the right is scan linear time once, right? The left is also scanning it almost once, right? Right. So if we're talking about the best case, the best case, the left didn't move. The left is 0. So let me go back, right? The best case, right? The left is staying at 0, right? And the right moved only once, right? So you have right all the way to n minus 1, right? So in the end, you have the O of n, right? So only scan once, right? Assumes this operation put is constant time, right? The cost is here, right? But we are assuming this is constant time, right? Here. So worst case, like what? Worst case is the left is like almost n minus 2 of n minus 1, right? I mean, almost close, right? And the right is like n minus 1. So the runtime is O to n, right? So be clear about what you're gonna talk, right? You need to look at what I did. That's how you express yourself, okay? I know you can just say ON, right? Some student would just say, okay, the runtime is ON. It doesn't help you, okay? Because the runtime is either ON or n square, right? What else can you do? ON square log n, right? You can just guess, right? Most of the time it's these two, these three, right? But you need to make a reasoning about it. So you need to explain it. Why it's ON, right? It's not good for you just say it's ON, right? I can say it's ON, but you need to give something, right? Because you can always say it's ON, right? Without any reasoning, right? So you need to let the interviewer know why it's ON, okay? That's how you express yourself, right? Express yourself is very important, okay? Okay, so that's the code here. Anyone have question about this code here? Okay, so let's continue, okay? Follow up. Google always like big data, okay? Like a distributed system, you cannot hold it in memory, right? So S is streaming in, right? S is very long. What does it mean, streaming in? Actually, Google actually likes this a lot. I think Google like it like so much. Almost like every Google interview would come with this, right? What if the S is streamed in, right? Remember longest increasing subsequence? I don't know if you have done it. The famous LIS, longest increasing subsequence. If you don't know it, try to look up it. It should be in lead code. Also, what if the S is streamed in? You can think about it. Okay, S is streamed in. What should you do? Right? What does streamed in means? Streaming is like let's say it gives you a class called stream. You can call the has next and the call next, right? The character might be the string. The character might be from a file, right? It's too big. You cannot. Let's say it's a 1 terabyte file. You cannot hold it in memory, right? Also, it might be coming from the network, like API call. It just call it one time at a time, like Hadoop, like one at a time, right? So when this happens, what should you do here? What's not working right now here? What is not working here in this code? So let me tell you, if that happens, this code doesn't work. Why it's not working? Anyone know? Which line? Tell me which line. Anyone know? Which line is not working anymore? Actually, the interviewer asked the candidate, which line is not working anymore? It's the exact same question, okay? I'm asking you, the Google interviewer asked the exact same question. Which line in this code is not working? Anyone knows? I don't want you to fail the Google interview, okay? Which line? 61. I don't have 61 here. Huh? 261? Maybe you mean 261. Anyway, 261. Here? Actually, that's not a keyword, actually. 264. No. Actually, okay, let me, it's 270 here. 270 here. Sorry. Wait. Yeah, it's 270 here. 270 here. Why? If you go back to the sliding window. Okay. So it means the right here is calling the next. Do you know? The right is actually calling the next, right? So here the right, you can get every time you get the right here, let's look at it. Here, s.char at right here. This is actually calling the string dot next, right? Here, you can get it. But you don't have the left. Why? You can't have this here. You can't have 270 here. Because this sliding window can be so big. You are not saving the string here, right? When you call s.char at left, this means you are saving the string here, right? You are not gonna save the string, right? Because the left has to be pointing to something. But with the data streamed in, right? Your left pointer is gone. You cannot have your left pointer point to some place, right? You don't have that anymore, right? That's the problem. You only have a right pointer here. So basically what it means, when you call s.char at left, it's not possible, right? So what should we do here? Okay, so here comes to the rescue, okay? We change the map. Instead of saving the count, we want to record the index. Let's look at this here, right? So here we are recording for A, right? The A, you can call it the rightmost index here on 12, right? You can have A here, but the rightmost here is 12. When for B, the rightmost B appear in 4, right? And on 10, but we care about the leftmost is 10, right? And the C appear on the 8, right? You can 7 and 8, but we only keep the last one, right? D is on 9. Why? Why does it help? Because if you look at the code here, when we only care about the count becomes 0, right? When the count becomes 0. So originally the map is saving the count, right? When the map is saving the count, because we care about when the count becomes 0, right? So when your index is 2 to the right of, let's say, if we look at B, right? If we look at B, if the index is bigger than B, if the index reach, if the left pointer now is pointing to, let me use the play mode. Okay, so if we are looking at B, right? If the left here is pointing to the 11, right? Pointing to 11. So so basically the count of B becomes 0, right? The count of B becomes 0, okay? Oh, it still saves this? Okay. Anyway, okay. So basically it's equivalent to count becomes 0, right? So if we look at our code here on line 284, okay? So we change the map to be character and the index. It's still integer, right? So what do we need? So when the size, the previous code is logic is still the same. So when the size is bigger than k, right? So you have more than k distinct character. We need to take out 1, right? What should we do here? We need to find look at this picture, right? Here. Let me remove it. How do I remove it? Okay. Anyway, here. Oh, sorry. So we want to find in this map, right? Here. We want to find. You see, we are looking at this map. We want to look at C, right? Because C is here, right? So if we cut off here, so if our left become here, this is our left, okay? This is our left, okay? How do we remove this? Oh, eraser, okay. Doesn't work. Oh, okay, never mind. I'm stop playing. anyway, so okay, let's go back. So the left is pointing to here. So when your left move to 9, right? All here, the C is gone, right? C is gone. You still have a C is gone, right? You only have A and B and D, right? So you have 3 distinct characters, right? So how do we find this? Let me erase all ink. Okay. Why the here is saved? Okay. Anyway, so what here is means that we just need to find the smallest in the map, right? Value is smallest. Okay. So how do we optimize? So the code is actually here. We try to find the leftmost, right? So let's go back. So here, when we found the leftmost, that's the smallest. We just need to remove that, right? So we just need to set the left to be the leftmost plus 1, right? You got that? No problem, right? No question. Okay. So here, how do we optimize it? Because this is doing a linear traverse of the values, right? To find the leftmost. What can we do here? Sorry. So the last follow-up, okay. Today's final question, okay. How do we optimize this one? Final question, final follow-up. That's the last follow-up for the interviewer. How do we optimize it? That's too quick, okay. First, don't talk about that, are you? So the first thing is priority queue, right? Priority queue. Priority queue is the maybe not the most optimized, but it's definitely the first answer, right? For priority queue, because you only need to get the smallest, right? That's a mean heap, right? That's a mean heap, right? But if the interviewer asks like, can you do better, right? So you can say like LRU. Some student doesn't understand what LRU here means, right? You can look at the code. So I'm not gonna talk about it. Priority queue maintain a FIFO, okay? FIFO sequence. So it basically have a head and a tail, right? Right? So it maintains a FIFO property. Basically, if you know it, it's just the linked hash map, right? Hash map. So basically, look at here. Every item has a pref. And next, it has a pointer to the previous one, and I have a pointer to the next one, and also it's using another map to track it. Okay, use a map to track it. So here, back to the our question, right? we want to find the minimum means what? We want to find so if we change this together, right? So basically the LRU would be like, oh, let's look at it here, right? Here. Let's see. So you first have A, right, in the map, right? Then you have B. B would be put it before A, okay? Like here, have a pointer to the A, right? Then A appear again. Then you would have A point to B, okay, right? Then you have A appear again. Then you have C. C would be here, right? C would be here, like this, right? This is the LRU hash, LRU. So every time the head is pointing to here, okay? This is the head, okay? This is the tail, okay? This is the tail, okay? Let's continue. So then you have D, right? Because C appear again is the same, right? C is still here. D is then I have to write more. Sorry, let me just wipe out this. So right, when you have D, basically it become like this: D, then C, right? Then I forgot it's B or A. It should be A, right? Then B, right? So your head is pointing to D, right? Okay. So if in here, if you want to get the first one, it will be D, right? LRU, right? Because this is the most recent, right? Then if B appear again, then you remove B. B become here, right? So now the head is B, right? Okay. So that's the LRU, right? So if the A appear again, then the A is gone. Then A is pointing to B. A become the head, right? Okay. So that's the LRU hash, right? That's the first optimization, right? So if you complete this step, you are very good on the interview, actually, right? So this is basically the end of today's class, also the end of that interview question, actually, right? So anyone has question? Otherwise, your class dismissed. Okay. Hopefully, you totally get what I teach about today. Okay.
Our public site, Xcode Career Service, you can scan the barcode to follow our site. We basically have training and classes every Saturday, 7 p.m. Pacific time. So if you are interested, you can always contact us, or you can join our WeChat group. You can add my WeChat ID. I will add you into our group. So welcome.